Welcome to the session. This session we are going to solve some of the homogeneous second order recurrence relations by using method of generating functions. So in the last session we know what is the generating function, what is the procedure to solve the second order homogeneous second order recurrence relation. So for that, what is a generating function we derive. So from that, I'm taking as it is from the last session function, generating function, and we are going to solve some of the problems related to that. Now, here it is given, find the generating function and solve the recurrence relation. So it is given as a homogeneous. It is given as a homogeneous because f of n is equals to 0. Now we are going to write this as, substitute n is equals to n plus 1. So it is a n plus 1 minus 5 a n plus, n is equals to n plus 2. n plus 2, 5 n plus 1 plus 6 a n is equals to 0. Then it is true for n is greater than or equals to 0 and given a0 is given and a1 is given. Now here the quotient of a n plus 1 is a we are taking. So a is equals to minus 5 and an quotient b is equals to 6. And now what is the f of x? What is the generating function for the generalized recurrence relation is a0 plus a1 plus a0 a into x by 1 plus ax plus bx square. Now in this I am going to take the values for a0, a1, capital A and capital B values. So this is a0 is equals to 1 and a1 as minus 2 and a0 as 1. 1 into a is equals to minus 5 by 1 minus 5x plus 6x square. So this is into x will be there. So it is 1 minus 7x by 6x square minus 5x plus 1. So which is this is the given recurrence relation and this is the generating function. Now this of course I am going to write it as 1 minus 7x by this by factors I am going to consider 3x minus 1 into 2x minus 1. Since this is 6x square, of course, minus 3x minus 2x minus 5x and plus 1. Or else I can write this as 1 minus 7x by 1 minus 3x. Just I took minus as common and here also minus as common. So minus minus it will become plus. So now either I can call this as the generating function or this as the generating function. Any one we can consider. Anyone we can consider. Now to solve this generating function, this is only finding the generating function. Now we are going to solve. We are going to solve the generating function. So for that we are going to take it as, once again by using partial fractions for this, 1 minus 7x by 1 minus 3x into 1 minus 2x. This I am going to take it as a by 1 minus 3x plus b by 1 minus 2x. Now this is by using the previous session way, just I am taking a into 1 minus 2x plus b into 1 minus 3x is equals to 1 minus 7x. So by keeping x is equals to 1 by 2, I am going to get b value. X is equals to 1 by 3. X is equals to 1 by 3. X is equals to 1 by 3. I am going to get a value. So from this, what I am going to get a and b values as, just I am taking a is equals to minus 4 and b is equals to, a is equals to minus 4 and b is equals to 5. Just straight away I am substituting x is equals to 1 by 2. If I am substituted, then this will become vanish. So b value I am going to calculate is 5. Then it is this. And x is equals to 1 by 3. If I am going to substitute, then I am going to calculate a value. So if I am just substitute 1 x equal to 1 by 2, 7 minus 7 by 2, 1 minus 7 by 2. So this will become 0. So b into 1 minus 3 by 2. So this is a minus 5 by 2 is equals to, then this is a minus b by 2. Minus b by 2. So this cancels. So what I am getting, b equal to 5. So which is similar. Now, after finding this, I am just substituting in equation 2. So what is f of x is equals to? F of x is equals to a by, a is equals to minus 4 by 1 minus 3x plus b by 5 by 1 minus 2x. So it is a minus 4, 1 minus 3x whole to the power of minus 1, 5, 1 minus 2x whole to the power of minus 1. So this is a minus 4 and this expansion is 1 plus 3x and plus 3x whole square plus and so on. Then plus 5, then this will become 1 plus 2x and plus 2x whole square plus 2x whole cubed and so on. So this is minus 4 summation 3x power n, n is equals to 0 to infinity, then plus 5 into summation n is equals to 0 to infinity 2x to the power of n. So now this is minus 4 and then summation 3 power n x power n. Of course, n is equals to 0 to infinity plus 5 and then 2 to the power of n x to the power of n, n is equals to 0 to infinity. Then what about f of n is? F of n is summation a n x power n. Now we are going to compare the coefficients of x to the power of n terms on both sides. So a n is 4 minus 4 into 3 to the power of n plus 5 into 2 to the power of n. So this is the solution for the given recurrence relation. Now let us go for the other example. See here, I am going to solve in the different way. Let us this problem. Then A2 is given, A3 is given. See, in earlier problems, it is only A0 and A1 are given. Now it is A3 and A2 and A3 is given. Of course, we are going to solve in the previous way also, but you just follow the other way whenever if you feel this is convenient, and then you go through that. So then this is, let us, I am just taking f of x, the generating function, which I am taking it as, let us take an x power n. N is equals to, I am just taking 2 to infinity. I am just taking 2 to infinity as the generating function. Now, if I am going to take it as a n is equals to 2, a2 x square, n is equals to 3, a3 x cubed, and of course, n is equals to 4 to infinity, then I am going to write it as the same. Then this I am going to take it as a2x square plus a3x cubed plus, what about an is equals to, then I am substituting n is equals to 4 to infinity an value. So what is given? An minus 8 an minus 1 plus 16 an minus 2 is equals to 0. This is the given recurrence relation. Now what about an is equals to 8 an minus 1 minus 16 an minus 2. I'm going to substitute that here. 8 an minus 1 minus 16 an minus 2, and of course into x power n, into x power n. So now this I am going to write it as, a2 x square plus a3 x cubed, then plus 8, then summation an minus 1 x to the power of n is equals to 4 to infinity minus 16, then it is an minus 2 x to the power of n is equals to 4 to infinity, n is equals to 4 to infinity. Now this I am going to write it as a2 x square, then a3 x cubed, then I am just taking 8x I am just taking common, then x I am taking common, then what I am going to get? an minus 2, sorry, this is an minus 2, an minus 1 x to the power of n minus 1, n is equals to 4 to infinity. Similarly here I am just taking 16x square, then an minus 2 x to the power of n minus 2, n is equals to 4 to infinity. Then these two terms will be the same, a2 x square plus a3 x cubed plus 8x. Then I am going to write n is equals to 3. What I am going to get? a3 n is equals to 4 x cubed, and n is equals to 5 a4 x power 4 plus and so on I am getting. So for that I am going to add a2 x square and I am going to subtract a2 x square minus 16x square, and n is equals to 4 a2 x square plus n is equal to 5 a3 x cubed plus and so on I am getting. Now this is a2 x square plus a3 x cubed plus 8x, and now all these things I am going to write it as, summation an x to the power of n is equals to 2 to infinity, n is equals to 2a2, n is equals to 3a3, and so on. Now the remaining is here, one more term will be there, so that I am going to consider it as 8 into a2, then x cubed, a2 x cubed minus 16x square, then this I am going to write it as once again an x to the power of n is equals to 2 to infinity, n is equals to 2 to infinity I am going to write. So let us, I am just taking what is the given assumption as, I am taking f of x is equals to this. So now this will become a2 x square plus a3 x cubed, and then this will become 8x f of x minus 8a2 x cubed minus 16x square into f of x, Now I am just taking these two terms to this side. So already f of x will be there here. So this is, I am going to write f of x minus 8x f of x plus 16 x square f of x is equals to, then I'm just observe this. This term is going that side and this term I'm going to take that side. Then what about the remaining terms? a2 x square. What is a2 is? 16x square. Then of course I'm just taking 16x square and next a3x cubed. What is a3 is 80. 80x cubed. a3x cubed. A3 then here it is what about this is 8 a2 x cubed will be there. Now what is 80? It is this for this, and now I am just taking for this minus 8 a2. A2 is 8 into 16. A2 is 16 into x cubed. So what I am going to get 16x square minus 80x cubed. Then so 128 x cubed. 128 x cubed. So which is then it is it is plus. I'm just taking this plus as a3. A3 is a plus. So it is a 16 x square. Then minus 48x cubed. 48x cubed. Now from this I am just taking f of x as common. Then it will become 1 minus 8x plus 16x square plus 16x square into f of x is equals to, so what is that? 16x square minus 48. 16x square minus 48 x cubed. So f of x is equals to, f of x is 16x square minus 48 x cubed by, this is I'm going to rewriting like this, minus 8x and plus 1. So this is the generating function. This is the generating function. Or else I'm going to take it as 16x square, I'm just taking common. Then it is 1 minus 3x by, then this will become 1 or else 1 minus 4x whole square. See, 16x square minus 8x plus 1. So this I am going to get like this. Now this is 16x square. Then I am taking 1 minus 3x by 1 minus 4x whole square. This I am going to write like this. Now just by using a partial fractions, or else directly we can write this as a 16x square by just it is 1 by 1 minus 4x, then plus x by 1 minus 4x whole square. So what I am going to get? 1 minus 4x and then plus x. So 1 minus 4x plus x is 1 minus 3x. So this is this one. So this is 16x square. Then I am going to write it as 1 minus 4x whole to the power of minus 1, then plus x into 1 minus 4x whole to the power of minus 2. Whole to the power of minus 2. So now this is equals to 16x square. Then this is a summation of 4x to the power of r. R is equals to 0 to infinity. Then 16x cubed. 16x cubed. This is whole to the power of minus n. So this will become r plus n plus r minus 1. So what is n is 2. So 2 plus r minus 1 cr. Then x to the power of r. R is equals to 0 to infinity. So this is 16, and I am going to take inside 4 to the power of r, 4 to the power of r, then it is x to the power of r, then plus 2. Then this is 16 x cubed. Then it is 1 plus r, cr, x to the power of r. So I am going to take it as taking to this inside. So r plus 3. Then f of x is what? F of x is nothing but a summation of a n x power n, a n x power n, a n x power n. So now x to the power of nth term, if I am going to compare, then this is a n is equals to then it is 16 into 4 to the power of what is this for what value of r? A n is equals to n minus 2, r to the power of x to the power of n. So n minus 2. So it is n minus 2, 4 to the power, r is equals to, put r is equals to n minus 2. So then it is r is equals to n minus 2. So it is n minus 2 plus 2. So n minus 2 plus 16, and r is equals to n minus 3. So it is 1 plus n minus 3, c n minus 3. So this is 16 into 4 to the power of n minus 2 plus 16 into n minus 2 nc3. So this is the solution for the given homogeneous recurrence relation. Or else if you can solve this, this is nothing but n minus 2 we are going to get, n minus 2. So this is, or else we can take it as 16 into 4 to the power of n minus 2 plus 16 into n minus 2 something. So this is the way that we are going to solve this. So this is the just A2 and A3 instead of giving A0 and A1. Here A2 and A3s are given. So we are taking the function in this form and we are going to get the solution. We are going to assume like this and we are going to find the generating function for that. And next after that we are going to find the solution for this. So this is the solution for the given recurrence relation, homogeneous recurrence relation. Now let us go for the other problem. Find the generating function and solve the recurrence relation. So which is given as like this. Now this is just we have to find out what is minus an. So if you want to solve this, this is also by using previous method we can solve, or else directly also we can solve this. Previous method f of x is equals to, then a0 plus a1 and so on also we can consider, or else in the other way also we can consider. So by just taking, put n is equals to n plus 2, n is equals to n plus 2, then it is a n plus 2 is equals to minus 3 an plus 1 plus 10 an. Now this is an plus 2 plus 3 an plus 1 minus 10 an is equals to 0, which is for n is greater than or equals to 0. So here this is the given recurrence relation. And here it is a is equals to 3 and b equals to minus 10. So now what is f of x is equals to? Either you can solve by using the previous method or else we can solve by using this this also. Both ways we can get the same results. F of x. If you want to solve this, then we can take this as a f of x is equals to, or else we can solve in the, this is a naught is a naught plus a1 plus a naught a into x by 1 plus ax plus bx square. Then this is a naught is equals to, what is a naught is 1, and then a1 is equals to 4 and a is equals to 3x by, and then this is 1 plus a is equals to 3x minus 10x square. So which is equals to 1 plus 7x by 1 plus 3x minus 10x square. So this is the generating function. This is the generating function. Now to solve this I am going to write in terms of factors 1 plus 7x by this I am going to write 1 plus 5x into 1 minus 2x. Just minus 2 and so on. So call this as equation 2. Now we are going to find the solution for that. So once again, by using partial fractions, so 1 plus 7x by 1 plus 5x into 1 minus 2x. So this is a by 1 plus 5x and plus b by 1 minus 2x. So in the same way, calculate the partial fraction, calculate a and b values. We can get a is equals to minus 2 by 7 and b equals to a equals to minus 2 by 7 and b equals to then 9 by 7. b equals to 9 by 7. So after finding a and b values, then f of x is equals to a is a minus 2 by 7 into 1 by 1 plus 5x, then plus b is equals to 9 by 7 into 1 by 1 minus 2x. Now this is, we are going to write it as a minus 2 by 7, 1 plus 5x, whole to the power of minus 1, 9 by 7, and 9 by 7, 1 minus 2x, whole to the power of minus 1. So this is a minus 2 by 7, and I am going to expand this, 1 minus 5x plus 5x whole square minus 5x whole cube plus and so on plus 9 by 7, then this is 1 plus 2x plus 2x whole square, 2x whole cube and so on I am getting. So this is minus 2 by 7 and the whole thing I am going to write it as minus 1 to the power of n and then 5x whole to the power of n. N is equals to, 0 to infinity or whatever it is. Then plus 9 by 7 and this I am going to write it as 2x whole to the power of n and n is equals to 0 to infinity. Then this is f of x is nothing but summation an x power n and n is equals to 0 to infinity. Then it is minus 2 by 7 and summation n is equals to 0 to infinity minus 1 to the power of n, 5 to the power of n, x to the power of n, 9 by 7 summation 2 to the power of n, x to the power of n. Then here just we are going to compare the coefficients of x to the power of n terms on both sides. X to the power of n terms on both sides. So an is equals to minus 2 by 7 minus 1 to the power of n, 5 to the power of n plus 9 by 7 into 2 to the power of n. 2 to the power of n. So this is the solution for the given homogeneous recurrence relation. For the given homogeneous recurrence relation. So in this way, we can solve the homogeneous recurrence relations. Now we just concentrated only homogeneous recurrence relations. Now, in the next session, we are going to solve non-homogeneous recurrence relation in the similar manner. We are going to complete. Here, so far, I am not going to consider g of n. So g of n, I took 0. G of n, I am going to consider. G of x, I am going to consider it as 0. So if I am going to consider, then we are going to get one more term extra. And in the next session, we are going to solve some more problems on non-homogeneous recurrence relation by using method of generating functions. With this, I am going to conclude now. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.